Folks, my name is Madhu Kashyap. I'm the OpenStack product manager at Brocade, and with me is Prakash Kaligotla, who's senior manager of software engineering. Today we're going to talk about the on-demand data center, which is really topical based on what you're hearing at the summit. It's all about cloud and elasticity and how you bring in different NFV functions like load balancers into it, and how you scale your data center based on your workloads and the requests coming in. So if you look at how workloads scale today based on unpredictable demand in your data center, you're really looking at two basic functions. You can either estimate peak traffic and then provision your infrastructure for peak traffic, and that can be wrong, and usually it is, and can also be very expensive because now you're provisioning all of this infrastructure without really utilizing all that infrastructure based on peak demand. The other option is to calculate average traffic and then provision your infrastructure for average traffic. And again, that's fraught with errors because you really don't know your average traffic. And then when you hit the peak, then you get the bad user experience and your infrastructure can't handle the traffic. So these are the traditional solutions today, but with OpenStack and cloud, you have the notion of elasticity and scale, which is what we're going to sort of talk about in this presentation. So with elasticity, which is one of the key characteristics of cloud as defined by the National Institute of Standards and Technology, you have the notion of auto scaling based on workload demand, and then resources are spun up on demand and then shut down as the workload demand reduces. And we're going to talk about how you use OpenStack with Ceilometer and heat templates to be able to create this on-demand scalable data center. And again, so the advantages definitely over more traditional provisioning methods are it's simple, scalable, automated, and flexible. So this gives you an idea of how we can use some of these tools within OpenStack to be able to create this on-demand data center. Here's what the use case looks like. So we can do it two ways. One is by hit count. When the number of clients increases on your workload, we can actually monitor, say for instance in this use case, we can monitor the load balancer, look at the number of connections coming in, and based on monitoring that, we can spin up the number of instances for your workload. So whether it's an e-commerce workload or some kind of content management system, it doesn't matter. So Ceilometer will continuously monitor the load balancer and then call the heat templates to spin up multiple instances. The other way is for Ceilometer to monitor the some kind of resource utilization, whether it's CPU utilization or network bandwidth or storage IOPS. Again, you're looking at resource utilization, and if it hits a certain threshold, you spin up more instances, and if it falls below a certain threshold, you can shut these down as well. So with that, I would like to hand over to to Prakash, who will walk you through the topology and the rest of the presentation on the on-demand data center.
Thanks, Madhu.
Thanks, Prakash.
So as Madhu was trying to explain, we will use Brocade's infrastructure, and we will use basically heat and Ceilometer components of OpenStack to demonstrate the on-demand configuration of the data center, as well as demonstrate the elasticity piece using Ceilometer. So here, as you can see in the topology, we have various racks connected to our VCS Ethernet fabrics technology. It can be basically a distributed Ethernet fabrics. It's a flat network, which acts as both the access and the aggregation. So it's actually a spine leaf layer. And that is going into the core, which is connected, which is basically our MLXC chassis, which is connected using MCT trunking technology. And the load balancer, which is the ADX, is as a one-off onto basically the core. So using heat, what we want to do is we want to basically deploy an application. We have used an application called WordPress, which is a blogging website. And we would like to use that to deploy it and create two subnets, one for the database tier and the other for the application tier or the web tier. And whenever the load increases, whenever the traffic increases on the application tier, we would actually monitor the incoming traffic and expand the application tier or the database tier appropriately. So here, I'll just go over the heat template, how it is defined. So here, I've defined in the heat template a auto-scaling group. Here, you identify what are the resources which need to be deployed using heat. And I have basically a server, I have a server image with a WordPress application installed and bundled with that image, which will be deployed to basically the VM instances. So this is a server, and when I'm creating a VM instance, it is a WordPress application which is getting deployed onto that VM instance. And there is also a database component of it. So I'll also deploy the database, MySQL database, into the database tier as well. And that's what I'm defining in the heat template on the right-hand side. And then I'm also basically provisioning the load balancer using a heat template as well. And that's what I've defined over here as a pool member. I'll provision the ADX to configure it as a VIP, as a load balancer for this app tier as well as the database tiers. And then I've defined a scaling policy to say if the number of incoming connections are more than 5, then automatically scale up the database tier as well as the VM tier to add more VM resources or compute resources to it. And again, basically the scale down policy as well. If the demand goes down, then automatically destroy or remove some of the VM instances from either of these tiers. And this is just an alarm definition to trigger what kind of alarm needs to be triggered by Ceilometer, what does it need to monitor, and what it needs to trigger as well. So I mean, this is the physical infrastructure. From this physical infrastructure, when I take basically heat, it's first going to configure a VM in the application tier, then a VM in the database tier. I've used the other racks on the right-hand side to configure the database tier and the racks on the left-hand side to configure the application tier. So right now, we'll start simple. We'll just have one VM in the application tier and one VM in the database tier. And then you also configure, since basically the application tier needs to talk to the database tier, you would also deploy a heat template to configure a Viata vRouter, Brocade Viata vRouter as a VM instance as well. And that is actually routing the traffic between these two subnets. Now, the heat template could also be used to configure the layer 2 segments onto the VCS fabric. Once it creates the VM instance, it creates the vRouter instance, it can create basically the subnets, extend the layer 2 networks onto the physical infrastructure as well. After that, it will provision the ADX to create the VIP, which is the load balancer. So then the heat is deployed to monitor for the Ceilometer alarms as well. So now we'll see, based on the demand, how our integration with Ceilometer will automatically start deploying or increasing the app tier and database tier. So now on one fine day, basically clients start using it. So client 1, client 2 have started using the application tier, no issues because it is still within the limits. Now 3 more clients have started, but still no issues because this is still within the limits. As soon as the 6th client starts, then there is an alarm which gets generated onto the Ceilometer aspect. And now the heat template, basically that is actually getting triggered. And what it is doing is it is going and creating a new VM on the app tier, a new VM on the database tier. And at the same time, it will go provision the ADX, the load balancer, to say these are the 2 new members of your load balancing pool. And yep. So that is in theory basically how it works. So due to the interest of time, we didn't have a working demo over here, but we do have a demo, so we have it in the booth. If you want to basically come over and join us, take a look at the working demo, you can come over to the booth, and we will make these templates available in Git as well. Thank you, guys.